Hello everyone, welcome back to Geospatial Intelligence PH, your go-to channel for learning GIS, mapping workflows, and spatial analysis. And if you're new to this channel, don't forget to like, subscribe, and hit the notification bell so you won't miss any of our upcoming tutorials. So let's get started. The first thing that you need is your data set. In this tutorial, the data that I am using was downloaded from Visual Crossing Weather, and I will put the link in the description below. If you don't know how to download weather data from Visual Crossing yet, I will also include a separate tutorial link in the description so you can follow along step by step. Now, as you can see in my dataset, I already have sample stations within my specific study area. These include the coordinates, which are the northing and easting values, as well as the wind speed and wind direction values. These are very important because we will use them to generate raster data and analyze wind patterns based on weather data collected from satellites and monitoring systems. Once you already have your data set prepared, make sure to save it as CSV-DOS format, because this format is compatible and easier to import into ArcGIS Pro. Now that your data is ready and saved as CSV, let's go ahead and import it into ArcGIS Pro. To do that, go to the Map ribbon, click Add Data, then locate your saved CSV file and import it into your project. After importing, open the table by pressing Ctrl+T so you can verify if all the data fields are correct. Always double-check your coordinates, wind speed, and wind direction values to ensure accuracy before proceeding. Once everything is correct, we will now convert the CSV data into a spatial dataset. To do that, right-click your CSV file and select X, Y, Table to Point. In the parameters, set your input table to your CSV file, then define your X field as easting and your Y field as northing. This step is very important because if you assign the wrong fields, your data will be plotted in the wrong location. So make sure that X is always easting and Y is always northing. For the coordinate system, you can use the current map's coordinate system to match your base map, then click Run. After running the tool, your point data should now appear correctly on the map. These points represent your wind stations. Now let's proceed to the first major step, which is generating a raster for wind speed. Go to Geoprocessing Tools, then navigate to Spatial Analyst Tools, select Interpolation, and open the IDW, Inverse Distance Weighting, tool. IDW is a method used to estimate unknown values by averaging nearby known values, where closer points have more influence than those farther away. This means that locations near your stations will have more accurate interpolated values. In the IDW parameters, select your point dataset as the input, then set the Z-value field to your wind speed. Define your output raster location, keep the other settings as default, and click Run. This will generate your wind speed raster. Once the raster is created, we move on to the next step, which is creating a fishnet. A fishnet is basically a grid that divides your study area into equal cells, and this is useful for organizing and analyzing spatial data systematically, especially for visualization of wind patterns. To create a fishnet, go to Geoprocessing Tools and search for Create Fishnet. Set your output location. Then for the template extent, use the extent of your generated wind speed raster so that your grid will match your data coverage. For the cell size, this depends on your dataset resolution. In this example, I will use 0.01 for both width and height, which produces a finer grid. Remember, smaller values create more cells and more detail, while larger values create fewer but bigger cells. Make sure to check label points because this will generate centroid points inside each cell, which we will use later. You can choose polygon or polyline geometry, then click Run. Next, we repeat the IDW process, but this time for wind direction, to generate a separate raster layer for direction values. After generating both rasters, we now need to transfer or interpolate these values into the fishnet label points. To do this, go to Geoprocessing Tools, Open Spatial Analyst Tools, then go to Extraction and select Extract Multi-Values to Points. Set your fishnet label points as the input, then add both your wind speed raster and wind direction raster as input rasters and click Run. After processing, open the attribute table of your fishnet label points, and you will now see that the wind speed and wind direction values have been successfully extracted and assigned to each point. This means ArcGIS has analyzed and transferred the raster values into your grid system. Now let's move on to visualization. Open the Symbology panel, and instead of using a single symbol, we will use graduated symbols because this allows us to represent variations in data, making the map more informative and easier to interpret. Change the symbol to an arrow to represent wind flow. Set the field to wind direction, and for normalization, use wind speed so that the size or intensity of the symbol reflects the strength of the wind. Increase the number of classes to 8 instead of 4, because more classes allow better differentiation and a more detailed visualization of wind variations. Then expand the Vary Symbology by Attribute section, enable rotation, and set the rotation field to wind direction. Change the rotation style from arithmetic to geographic so that the arrows correctly follow real-world directional orientation. At this point, your wind map should now clearly display both wind speed and direction using arrows, giving you a more dynamic and meaningful visualization. Finally, you can enhance your map by adjusting colors, base maps, layout design, and other visual elements to make it more attractive and professional depending on your preference or presentation needs. And that's it. You have successfully created a wind speed and wind direction map using ArcGIS Pro. If you found this tutorial helpful, don't forget to like, subscribe, and follow our Facebook page to support the channel and inspire me to create more videos like this. Thank you for watching, and I'll see you in the next tutorial. Happy mapping!